whether we're thinking, oh yeah, thanks. What ways in which we've kind of developed the atlas to try to provide that information on current species distributions and thinking about projected changes in habitat for both trees and for birds. And in order to do that, first we want to go through a few of the basic components of the atlas so that we can all kind of be thinking about it as we kind of go to a tutorial. And really, the Atlas project started almost 2 decades ago, and we're kind of on the fourth version of it now. And so it was really led by Louis Iverson and Nath Prasad. And then I joined about 2002 working on this project, and Matt Peters shortly after that. And we've continued to go on it. And it's really great to see how it has evolved. And this slide really depicts, in some ways, some of the three key components that we will find within the atlas. So for each tree species, right, each of the 125 tree species, we're interested in a couple components. One is thinking about the distribution of species across the eastern US. The next will be thinking about what is the potential for those trees to actually move within the next century, so this migration potential. And then also thinking about all those characteristics that we don't necessarily model, but we know are important, right? Things like life history traits and characteristics that we can quantify. So just to give a little bit of a visual about what that looks like, the first component is thinking about habitat suitability, right? We can think about a current species distribution, right? We can say, okay, basically from forest inventory analysis data, where does the species occur? And our primary question has been, well, why do they occur there, right? And so we want to think about the different environmental drivers that are important. So whether it's climate, right? Temperature, precipitation, whether it is soil characteristics and properties or elevation, right? These are all the characteristics that we try to understand, what it defines a species and its distribution. And then if we can do that, right, then we can think about how do those habitats potentially change under climate change. So notice I'm talking about habitats, right? Because we aren't saying the species is going to be somewhere, but we're thinking about where do those conditions occur under these different emissions scenarios. And that really is the basis, right, for us to think about those habitat potential changes, sense for under lower emissions and higher emissions. And we'll talk about that as we kind of do a tutorial. We can think about what that means a bit more. The next component of that, right, is we think about what is the potential for this particular tree to its habitat may be suitable, here way up in New England, but what is the likelihood that that species would be able to make it there on its own? And that's where we go and we want to understand what is the colonization potential for those to occur, right? And in this case, we have our distribution model of understanding where that species habitat is located. And then based in a couple of generations of that tree, what is the likelihood that it would be able to colonize? And so essentially, as we have the blues, there's a higher likelihood of infilling the range, expansion of a little bit of a couple 100 kilometers. And then really, though there's habitat further to the northeast, there's very low chance of it actually being able to make there, right? So that's an important dimension of the atlas we want to think about. And then that third component, right, that we were talking about a little bit are what are some of those characteristics that are in many ways just as important as we think about how species may respond to climate change, right? What are the life history characteristics that define a species, right? So thinking about biological factors, right, such as shade tolerance, or thinking about factors that relate to disturbance. How does it respond to fire? How does it respond to floods and disease and those aspects? Right? And by doing that, basically going through the literature for all of these species, we can come up with an index, right, a relative scale of thinking about adaptability to change. So a species like red maple that has a lot of these positive traits, competes for light well, right, can grow in these different conditions, has a relatively high adaptability score that we would give based on those characteristics. Whereas a species like balsam fir, right, susceptible to insects, disease, right? Think about range of temperatures, right, has a relatively lower adaptability. So we can combine all those information to think about our cumulative understanding of how species are capability to cope with climate change, right? So that's kind of the core components. And what I want to do now is really kind of go to the atlas and try to give you a sense for what this looks like. And so this is what it's going to look like when we come to the home page, right? And we can pick a tree and kind of walk through that. So let me just escape out of this presentation here and move over just to the web for a minute here. So I'm just gonna start from scratch, right? In terms of what we want to think about in terms of the climate change tree and bird atlas. So we're not talking about birds today, but it's really analogous to our tree atlas, where we use the individual tree species as important predictors in terms of bird distributions as well as climate. So what I kind of present here will be a similar kind of component. And I also want to mention, at this time too, and I'll mention it again later, there are these really great tutorials, right, that really kind of walk you through these different components of the atlas. If you're interested in coming back to it, you'll notice, right, we're basically on Atlas version 4, right? So if we click on it, we come to this page where we have a list of a couple of 3 species here, but we can really select any species that we want out of the list. I will just start off with sugar maple, but if you have one that you really want me to look at in time, then holler it out or chat it in and we can go there. But I want to spend about 10 minutes just trying to walk through this for everyone so you can get a sense for what's there. So I'm going to start with sugar maple. And the first thing that I want to point out is a pretty important piece, right? And that is this idea of model reliability, right? So that's really assessing how well are we able to capture the distribution of sugar maple in this case in the eastern United States under current conditions. And so you get a sense for this is the distribution of the forest inventory analysis data. And basically in our kind of grid, you'll notice these grid cells in the Corn Belt area are a little larger, right? Because there's less FIA plots. So the resolution is a little coarser, right? So it's 10 by 10 kilometers versus 20 by 20 kilometers. So from that, right, we can think about what are the important variables that come into describing and capturing the species distribution. And so that's where we use, right, our tools and models to develop the species distribution model. So we can then model that species distribution, and it should look pretty much like the inventory data, right? So it's a little bit smoothed out, right? And we have high reliabilities. We have confidence in this ability for us to capture sugar maple in the eastern United States. And so you may ask, well, what the heck's going into that, right? Well, what's going into that are those important environmental predictors. And so if you were to scroll down, right, under this predictors, we see a suite of precipitation, climate and temperature variables, right, elevation variables, and then soil characteristics and properties. And if you notice these kind of values in brackets, right, these kind of are indicating those variables that are most important in describing the species distribution across the eastern US. And if you really wanted to look at what soil calcium carbonate looks like, percentage across the eastern US, right, we can look at that too, right? And these are the predictors that are within the model. So we have a soil variable being really important for sugar maple, but we also have growing season precipitation being an important predictor, right? And so once we have that, right, that's where we are getting this model of this current distribution. And then we can think about, okay, how does this potential habitat change under different climate change emission scenarios? So I'm just going to pick the average. We have 3 different climate models right here, right? And we can do the average of those if we want to get a kind of a general picture of those, and we can look at it under high emissions or moderate emissions, right? In this case, and kind of get a sense for how those habitats are likely to change from their current conditions. Right. So this maybe wasn't the best species to pick, right? Because if we think about shift, right, really, throughout its current range in the eastern US, it's pretty much occupying those northern components. So let's just switch to southern red oak, right? Just for the fun of it. Just to see how easy it is to switch over to a species. You notice our model reliability is medium, so that's still pretty good. We may want to think about how does that habitat potential change under different scenarios, right? And then we can see what is the likelihood of that species being on a colony. So that's kind of way we can look at that. You also notice here there's this interpretation that really kind of captures our overall summary of the entire kind of picture of what's happening within a given species, which can be helpful. You'll also notice at the bottom, there's these summaries that give, percent change, how much the species protected habitat to increase, right? In those. The adaptability piece is that third piece, right? And that's really thinking about those different environmental characteristics different life history characteristics that make up that species. In this case, we're on southern red oak now, right? We can get a sense for, right? We know there's challenges in terms of thinking about intermediate tolerance, right? Regeneration, right, becomes a challenge, right? So we can get a sense for how that falls in line with it, right? Or and then how it responds to these disturbance characteristics. So getting a sense for how that looks, right, relative to a species like red maple, just because we're doing it.
Hey, Steve.
Yep.
Just a question. I was typing another message, so I'm not exactly sure what this corresponds to, but
Yeah.
Rick asked over what period of time?
Awesome. Thank you.
Mhm.
Cool. Yeah. So that's a great question. And so these maps here are towards the end of the century in terms of habitat. So we do it in 30-year intervals, but what we're showing here on the atlas is the end of century kind of projections of habitat change. And that's why that shift component of colonization is really important, right? Because we don't expect those species to want to make it there in 100 years. Great. Awesome. And so then just back to adaptability, right? We see why a species like red maple has such high potential adaptability, right? Because all these scores from the literature, used heavily with Silvix North America, but other primary sources of literature, right, would really have these biological capacities being relatively high. Right. And so essentially there's lots of other ways you can go about within the atlas and you can explore, right? If you would rather just look at maps that are summarized, look at everything at once, you can do those, and it's pretty easy to download and then use in different situations and settings. So what I want to do now is, right, instead of just going back to the presentation for a second, the other really important component within the atlas that we've really focused a lot on in this latest version has really been to try to provide regional summary outputs, right? So how do we like stack up all those 125 species maps, right, into a digestible way that we can think about it for a given area, right? So for many of these different geographies, I didn't mean to click that, I apologize, right? We can think about national forests, national parks, we can think about urban areas. We can think about 1 by 1 degree grids, right? In terms of how do these data look in terms of a summary.
Steve,
So I'm just gonna, yep,
one more question before we get into that.
please.
From Jake, what is the difference between shift and the original selection?
Awesome, great. Yeah, so I'm just gonna I'm gonna go to American Beach. I apologize for skipping over so many species. I just want to give you a breadth of what that looks like. Yeah, so that's a great question. I appreciate taking the time to think about it. So if we think about the current habitat distribution of a species, right? Essentially, this is our model for American Beach, right? We can then think about how that habitat is projected to change by the end of the century, right? Shift is essentially coming in and addressing that question of what is the potential, right? It's a combination of habitat values and then a model that looks at identifying what is the potential for a species to colonize given areas over that next 100 years, right? So the next couple, 2 generations for that species. And so where these colors are more, where its current range is, right? Where places where there's high habitat, medium habitat quality, right? And also it's relatively close, so it's likely for it to be colonized, right? We can kind of think about those. And then we can think about areas, right, where it's really far away from its current edge of its habitat distribution. So it'd be really hard for them to naturally colonize by the end of the century. So that's the combination of a habitat model and a component that looks at the ability for a species to migrate on its own. That helps, right? So that's what this map is trying to do.
And just to verbally share what I just shared in the chat, because we had
Mhm.
another question about HQ and CL.
Yes.
So HQ is habitat quality, CL is colonization likelihood.
Yep, exactly. Yep. And so it's a mouthful to think about together, but yeah, thinking about how they go together is kind of the goal. Yeah. So just another tool for us to think about. All right. So hopefully that gives us a sense for where and so how we think about an individual species. That provides hopefully a lot of information. The next aspect we might want to think about are, within a given geography, right? So I'm just picking the Allegheny National Forest, right? We can go back and pick other areas, right? In terms of a map. You'll note that it's kind of buffered around those areas because it's really important that there's enough area that we feel confident that the summaries are representative of the potential changes for a given region. And there's two different versions, right, of the file you can look at, right? One would be a PDF version, right? And I'm just going to walk through this a little bit. So again, please keep those great questions coming as we go. The first page that you'll see is a general summary of not only just the species characteristics, right? You can get a sense for, I'm just going to make it a little bigger, right? Just general, taxonomic components, potential species, potential to increase within the region. So 17 or so species, potential increase, that's about 20% of their current importance value. Decrease, right? About 20 species projected to decline. So that's that important piece we're going to get to next, right? And then we have the potential for species to migrate within this region, right? We also wanted to provide information about climate, right, over this current century, just so as you interpret the species results, you can think about what is the change in things like growing season temperature, right? This is under the higher emissions Hadley model, right? So we go from an average temperature of 61, growing season temperature of 61.5 up to 75.7. So that's a pretty large increase, right, in Fahrenheit, 15 almost degrees. And then that can be juxtaposed, right, to how's precipitation projected to change. In this case, remain about stable to slightly decline by the end of the century. It's important contextual information, right? Before we start thinking about the information that's available for each species. So in this case, right, we can start to get a sense for some of the important components of these combined species outputs, right? So it's a big table, but it just takes a second to think about and digest it, right? And so don't be overwhelmed by this volume, right? The Excel one, you can do all sorts of manipulations with if you want, right? So I'm just starting off here at the top, right? We know in the Allegheny National Forest, National Forest, black cherry is important, red maple, sugar maple are important, right? So all I'm gonna just highlight just a couple of these columns, the model reliability first, how much confidence do we have in that, right? And then thinking about how abundant species is, so forest inventory analysis value, we use importance value. So we were thinking about the number of stems and basal area and summing that over that entire region. And then we're getting into the potential changes in habitat. So for red maple, potential larger declines in habitat under their high emissions. So more, a fairly large potential decline. Small decline is about 20% of its current habitat. Large decline is about almost 50% or so decline in its habitat, right? So that's that visual of the map right into this area for a specific geography. Adaptability are those life history traits, right, that we talked about. So obviously red maple is high. And if you combine this habitat, right, change with the adaptability, right, we can get a sense for what's its capability to cope with climate change based on this assessment, right? Though it has potential large declines, it's still really abundant within the region. And because it has high adaptability, it's still likely to fare okay, fairly good under climate change within the region. It's that contextual information, right? Whereas species like quaking aspen has lower abundance, large declines to very large declines, has okay adaptability, but essentially, has this poor potential to cope with climate change, right? So it's a way of putting this information together. Whereas a species like basswood, right, as increasing in habitat, has a potential to be very capable to cope with climate change. So those are all species that are currently within the region, right? If you were to scroll down, right, you can start thinking about what are those new species that maybe are on the edge of the region, but have potential to have new habitat within the area, right? We know that, species like shortleaf pine in the state or so south, right? They aren't currently within the Allegheny. They have potential to have new habitat within the region by the end of the century. And, they have this potential to migrate to some extent, right, in that time frame. So those are the pieces that we're trying to compare. I can go to another region if there's a little bit different information within some of the other tables, if we want to go there. Maddie, do we want to see? We were going to stop and see if folks had questions, but I can also go to another example if folks would like from this case.
Yeah, so don't be shy. If anybody wants to look at a certain region, feel free to shout that out or drop it in the chat. I haven't seen any yet.
Okay.
Let's see. So one question about that
Mhm.
last table of the Allegheny. Did that table show species likely to migrate into the Allegheny forest?
Yeah, exactly. And so I think what I wanted to do is kind of go back and maybe look at one or two of these species that might help like translate these numbers back into the components that we have. So again, let's keep, you all can keep me honest here in terms of thinking about these species, right? So let's think about species that may have, we'll think about, white oak has a potential to increase, so we'll look at that species really quick. We've already looked at red maple. But then also let's look at a species like shortleaf pine and Virginia pine, right? Or species that have potential to migrate within the region. Okay, and that's what's really nice about the atlas is that we can kind of it's important to go back to think about these species in going back and forth between table to understand that spatial distribution, right? So the current distribution for shortleaf pine, it's protected habitat, right? That's pretty getting into the Allegheny, some decent habitat quality, right? The HQ part of it. And then what's the colonization likelihood, right? It's pretty low, right? But it's also, so we can see this gradient from its current edge of its distribution, pretty high likelihood of colonization, right? To ports of West Virginia, potentially. It gets relatively low into Allegheny, but it's not zero. It's greater than 2%, right? Essentially is what that kind of value is getting at. So that's kind of how that table is kind of interpreting into those. That's one species that we could think about. And just to compare that to like white oak, that, it's a species that's there. It's obviously one of heavy management focus, in the Allegheny. We can, think about its current distribution, right, being present, potential changes under climate change, right, and that's where that kind of potential large increase. That's kind of how the tables work.
That's a really great tip to go back and forth because, yeah, Elizabeth, to answer your question, that is indicated in that table by showing you can look for the species that are very likely to increase or like a large increase, or it'll say new habitat in that habitat change column. And then you can look for infill, those words infill or migrate as well. But then going from this and not just, so this is just text summary, but then going from this and looking at the map is a really good practice. We also have two suggestions here, one for Northeast Minnesota and one for Wayne National Forest.
Cool. Yeah. So Wayne, we work a lot there, and we'll go to both of them. So we want to go let's do Wayne National Forest just as an example, and I'll just show you a different way to look at it in case you really want to dive further into it. And it's going to open up here, right? And so it's same data that was available via the PDF is also available for Excel if you want to start to manipulate and mess around with like these outputs, right? So it's the same climate information. Well, I mean, it's different climate information since we're talking about the Wayne, but the same table that we were just looking at, but in Excel form. So if you were like, I want to know, getting back to the question, what are the species that have higher infill, potential for the end of the century, right? You can start to sort it by that. So just to say, if you want to have a little more interactions with the data, you can do that. Basically, they're all sorted by the forest inventory analysis current abundance. That's kind of how they come. So we get a sense for that. But the other thing I wanted to point out with this, within the Excel sheets, each of these columns, that's a lot to remember, right, has a definition, right? And these are things that are within some of our papers. If you don't want to go back and dig out the the research papers, right, we try to provide like details about what each of these columns actually mean, right? So what do you mean by a large decrease versus a small increase, right? So, a small, no change is basically within this 20% plus or minus change in habitat. We get to small decrease, past that, and then we get to large increase and decrease. So it provides hopefully some of that text information. And I don't know if you want to do this, but you can also, if you really like numbers, right, and you really want to know what are all the nitty gritty behind these calculations, right? All of the actual summaries are there too in the Excel sheet. So just to let you know, because I think it's important to be transparent about where these summaries are coming from, but all the summaries are there. So that's Wayne, right? You get a sense for pretty similar to Allegheny, right? But you do have some pretty differences in species, right? A larger number potentially declining, right, in general, and Wayne than Allegheny. And that just has to do with geography. Northern Minnesota, just really quickly, let's just look at another region. We can do it in a lot of different ways, right? There is a map for these, right? So we can look at these regions if we want to. I think sometimes it's really helpful also to think about the regions in terms of the watersheds, right? If you really want to get a sense for some of these other ones. But that's an aside there. So I'm just gonna pick, I don't know why I'm picking a watershed, just for the fun of it, but I'm not gonna find one. Would need help probably. So I'm gonna go back to my vulnerability ones, just because might be easier. Minnesota, Northwoods, right? So in this case, right, we can see potential changes in climate, precipitation, right? It depends on the emission scenario, and as well as the climate model. These spark figures give a little bit of that, right? Pretty different patterns and potential species increasing and declining overall. A good number of species, right, have this potential. We see this potential for infill and migrate. Getting back to that question, right? But do you then start to see the different species, right, as they relate to these components? Quaking aspen, right?
Maybe a
Black spruce.
little
Oh
zoom
yeah,
again.
thank you. Oh yeah, I wish I didn't do that. Right, so we can think about some of those species, right, that have different sorting on the top of their list. Those more northern woods species, right? And then thinking back to like some of the other experiments, right, that are thinking about promoting some of these other species that are present within the area, right? We can start to get a sense for where those decisions were coming from, right? Species that were further down in the table, like northern red oak, right, and its potential to increase and be very good. So you start getting into those questions of your local knowledge about how suitable, how present is the species is something you want to promote. And this provides at least a little bit of a table summary of those species. And likewise, right, we can start to get into species that have potential to infill within the region, right? Maybe they're relatively low currently, maybe on the peripheries, they're not very abundant, but have a potential to increase in habitat. And this kind of idea of filling in within the region. All right, that's a lot. I'm kind of going, I don't want to get too far deep in the woods because I can. So maybe I should move on to some other examples, thinking about the time, or unless Maddie, you want me to explore any other components there.
Yeah, I'm not seeing,
Okay.
I did share just now for everyone, our ecosystem vulnerability page on forestadaptation.org does summarize these results. So we have like PDF handouts that summarize these results for your region. Since most of you are within our kind of main footprint. So that is a really great starting point, and then like coming to the tool to really poke around to explore those results some more. So just wanted to let folks know that those exist. I am seeing a couple other comments. David said, I saw they use soil as a value. Does it include soil depth? The soil was pushed from northern Minnesota to southern Minnesota by the glaciers. We have 0 to a couple feet typical in northeast Minnesota. Also, how do you weigh northern red oak wilt into your management consideration?
Yeah, those are excellent. I mean, ways important to think about it. And again, like it's great when everyone's kind of thinking about these questions. So yeah, like soil depth is a predictor. So we have soil properties and soil characteristics. I can't remember all the specific soil variables now. I think we might have it, definitely thinking about things like permeability, depth to bedrock, and those species that those variables are really important, right? They will certainly limit those distributions, but it's a combination of these variables. So, it's important to think about which variables are really driving a species in a given component. And we found that the soil variables are really important within these models. They make them, in many ways, much better able to capture the current distributions and also put those limits on a lot of these big changes, with high abundance. So they're important. And that's kind of there in the individual species. Yeah, and then also thinking about like disease, oak wilt. Yeah, that's something where, this conversation, working with EVAS is working with local partners. I mean, those are the realities that local managers know best, right? And so they're not explicitly within the models. And so that's part of the conversation, right? Do I promote or not in face of these components? And that's really where that dialogue is important. Who is actually needs to make the management decisions. So we don't have disease and pests and pathogens directly in the models. I will say we are working on other aspects in our group, in our landscape change research group, to address contemporary changes and how that intersects with our climate change work. But ultimately, I think we feel really strongly like working with partners is the best way to have agency over those decisions, right? This is a guide, right? In many ways. Yeah.
Great, thank you. Let's see, one shorter, easy to answer
Yeah.
one here, and then another a little more in-depth one. So are there data files on the website that we can download for use in our own GIS projects?
Yeah, actually, yeah. So there are, I don't know, ooh, can I get there this fast? Yes. There are these data for all of the tree species models are on the date, and I'm gonna get it wrong. I get my acronyms wrong. I apologize. I can follow up with it, but they're all available on, I believe the they're all archived in the Forest Service database. So all of the tree species models and predictors are available in shapefile format. So you can grab them and look at them in any way in which and in what you would like. So yeah, so individual tree species information are available. And then the summaries, right, they're all available here on the Atlas website in terms of getting those. So it's a good the combination, especially if there's like specific inventory data, you want to overlay your own inventory data with what the Atlas is saying, because that's relatively coarse. That's been something that we've really been excited about to see people do and to see kind of how they line up. So yeah, the data are all available. If you go, yeah, go for it, Matt.
Yeah. Oh, I think maybe you're just about to say that. Where can folks actually find the shape files?
Oh my, should I try to find them? Well, there's a couple ways you can find them really, really quickly. If this still works, we have been having some issues, I will say, with the website lately. I think this is out of date, unfortunately. But these they're not going to go. If you go to the tree search papers, right, they will then link to where you can download the full data set, essentially. You can also get it via the data archive system within the Forest Service. And I can follow up with that if someone
Yeah, we can put
post
that.
them after.
Yeah, when we send our like weekly newsletter that everybody's getting after their discussion sessions, we can make sure to share that, since it seems like a few folks are interested in that. Okay, great. That was that. And then Max is asking if working in a smaller area and FIA data does not accurately represent true importance values in the area of interest, how might we interpret these models differently, focus more on habitat and species adaptability?
Yeah, I think that's a great one. I'm sorry, I apologize going back and forth, asking these questions that make me want to go back and forth and explore it. Right. So one area that we do provide, basically every one of these 1 by 1 degree grid cells, right, has an associated table with it. And really what we've tried to do with our model, with our approach, right, is if we went back to an individual species, right, our approach of 10 by 10 degrees and 20 by 20 degrees, right, these are all represent enough FIA plots that we can kind of, generate these models, and then recall that we are creating a distribution of those species, right? In many cases, when it's kind of under current conditions, right, it does fill in some of these areas. So the taking the results that are kind of summarized at this level, and then when we do the 1 by 1 kilometer, 1 by 1 degree latitude summaries, right, we're essentially identifying a spatial extent that we feel in many cases, right, can have enough support, right, to summarize the data, right? So this is, I'm just picking a 1 by 1 degree grid, right, in a place that's not very forested. But we can begin to think about what are the projections within that location, right? The values are going to be much lower, right, in terms of the abundance of species, right? But we can, it's a very short list, but we can start to think about those species. So try to take that into account in our approach of how we're thinking about development, if that helped. But I think it is important to rely on those other resources too, adaptability. And we're going to get to an example in a bit where outside the Eastern US, how you can start to think about those questions as well. So maybe I'll save that for once we get to there, if we get to there.
Yeah, great. And just while this screen is up here, just to
Yep.
point out, because I do see some folks from our urban
Hmm.
discussion group, you can click on that urban areas under the summary tree tables as well and find your metro area. So
Yeah, and then, yeah.
I do think with time we should maybe transition. So
definitely. And with the urban tables, it provides, it only has another couple of columns about like the amount of forest within a buffer and then within the city center. And so there's a little bit of different information there to provide that contextual information. Yeah, great. Awesome. We did this. We did the demo. This is just to say, right, again, to point out to the tutorials that, kind of walk you through each of these components, right? So you don't have to remember everything that I said. Now, if you want more concise kind of summaries, this can also be a good resource for thinking about, deciding how big of a region do I need? Do I pick a Huck watershed or a 1 by 1 degree grid, and some of those questions that often come up. Those thinking about time, we kind of did our questions. This is good to be out of order. Do you want me to kind of give a quick example of this, Maddie, or should we go on?
maybe we could circle back to it, but I think touching on heat and hardiness zones,
yeah,
maybe
yeah,
more.
cool. Yeah. So I was going to give an example of how the tree atlas is used in these larger experiments of adaptive silviculture for climate change component. And again, it kind of gets to the point that much more work needs to be done at the site scale, right? But there are ways in which the atlas data are being incorporated into those studies that address silviculture, both in urban areas, right? There's an Ask project that's more related to urban components, as well as in our kind of more. So it's a really great way to see it. So this question, kind of relates back to what happens when the tree atlas isn't there. I will say, like right now, we are very actively working on, we have models of 300 and some species that cover the entire North America, that we're really close to having that out. And so this will be less of a problem, right, in the coming years. But there are still lots of other ways, and I think it's also important to recognize that other data are really important in making decisions about how climate change will be influencing vegetation, forest, right? And one way that can be helpful is to think about those important predictors that drive species distributions, like growing degree days, plant hardiness zones, heat zones, right? And this is a product that we had developed a few years ago to try to address that at more of a conterminous USA scale, right? So this is essentially mapping the distribution, right, of plant hardiness zones. So think about that in terms of minimum temperature across the U.S. Under current conditions, right, and under those different emission scenarios on climate change models. In this case, RCP 8.5, right, by the end of the century. And we do this in 30-year time chunks, right? So you can get a sense for that change in plant. And in this case, we're looking at plant hardiness zones in before and after, right? And so these data, I did provide this, right? These are provided in AGOL kind of service, so you can kind of click through them and look at those different components of current conditions and potential changes in those three metrics through time. If you want to download them, right, it's a little easier to download them. You know, essentially, as you would with any AGOL kind of server, right, you can essentially download and then look at and get those values for any place across this geography. So you can kind of have a chance to play with those in real time and in that platform. One way, and others have developed these, so I will make sure that this isn't necessarily this is a really great way of thinking about it, but I can't take credit for this thinking. It goes back to Leslie Brandt and others, right, in terms of summarizing how you can think of and many others, NIAX and Climate Hubs in OSC, to think about how you can use some of this other information, right? But one way is just, again, it's analogous to thinking about life history characteristics. It's also thinking about where the species distributed. So if we go further west, where the current atlas doesn't reach, right, we might have this Black Hill spruce, right? We can think about what is its current plant hardiness zones from those maps, right? 2 to 8, right? Heat zones 1 to 7. We can think in that area, what is the projected changes in those same metrics, 6 to 8. So still within the range, and then heat zones, that's above 85 degrees Fahrenheit. We have 7 to 8, right? So we see this component for the species under future conditions, right? We'd expect to be little impact on the hardiness zones and the minimum temperature dimension for the species, but certainly getting into that larger potential negative impacts for species on the other in terms of the warmer summer temperatures, right? And so this potential for the number of days above a certain value becomes a tool that can be used to start to think about those components. The other important tools, right? Like I mentioned, there's a million tools just to highlight here, especially for Western sites, right? Would be seed lot selection tool, of trying, again, using kind of climate matching to think about a given location and how does that region potentially change as we think about those climate conditions. So the seed lot selection tool, if you're not familiar with it, right, it essentially has these 16 variables of temperature and precipitation, right? We can think about how those conditions match future areas in terms of climate. So identifying areas where seed coming from, right, that would match what the future projected location is to be, right? So to say you have a location, you can click on a map of those coordinates, thinking about the climate scenarios in terms of how they're projected to change, right? And it kind of gets this idea of transfer limits, right? We're thinking about planting. So in this example, right, we have an example, here, like if you're thinking about in Idaho and then matching those areas of where those climate conditions at the end of the century would kind of correspond to your current of guiding those seed lot areas. So those are two other tools, right, that we can start to think about as you start thinking about these decisions, important decisions that are decades in the future, and how do we kind of go about kind of making some of those components. So I just ran through that really quickly because I wanted to make sure we left time for questions and other ways, or if we wanted to go back and address some other questions related to that. So with that, maybe I'm going to turn it back over to you and help us wrap things up, in a way that we want to.
Yeah, thank you so much, Steve. People are sharing comments about definitely getting a lot out of this and wanting to watch this over again. So we will be sharing the recording in our newsletter. And yeah, as for the seed lot selection tool there, I know we have at least 2 folks in the room who either have nurseries or are coordinating nursery operations. So that's definitely something to check out for you folks. I did want to share too, Steve. I don't know if you could show that Black Hill spruce slide again. But just that approach with comparing known heat and hardiness zones with projected ones based on that tool. Yeah, so I just wanted to mention that with this, this is the approach we took with a lot of urban species, because the tree atlas is really looking at, it's 125 different native tree species to the eastern US. We had to, for a lot of the cultivars and non-native species that are present in our urban forests, in order to assess their vulnerability and adaptability to future climate change, this is the approach we took with a lot of those. So just wanted to share that if you are in an urban area and you're interested in taking a look at a certain species, but it's not in the tree atlas, this is an approach you can take yourself or reach out to me and I can walk through this with you. So yeah, just wanted to note that. Steve, you're muted.
Yeah, I was gonna say, just to add to that too, I mean, the addition that you have made, with the other traits that are more relevant to urban areas, I think is another important thing to point out too, right? Those other life history characteristics, those feed into that modified adaptability score, which are great. So just to say, it's both dimensions.
Thanks for mentioning that. Yeah, so the adaptability scores we're giving to urban species are also including things like salt tolerance and root zone restriction and all of those, considerations that are important in a more developed environment. Thanks, Steve. So yeah, one question here I think is a great one. Could you summarize the basic steps that someone new to this data would utilize?
Yeah, that is. Yeah. So I always say, like, kind of entering into it, I think it's really well, I think watching those little tutorials are only about 3 or 4 minutes. I think it's often really helpful to approach it from the idea of wanting to understand or dive into. You may already know, obviously the audience know a lot about individual species, going through a species and then essentially thinking about how it's built up from its current distribution. You don't have to dive into the predictors unless you're curious, but just getting a feel for like how those habitats are projected to change, I think is a good way. That interpretation kind of panel on the right there, that kind of gives essentially a text version of what we think are the highlights for any given species. And so now we'll say, like, Lewis Iverson took that on right before he retired, and it's a great download of all his knowledge. So it's a really great kind of summary of the things that we're thinking about when we look at these series of results. And then I think about, once you kind of get comfortable with that idea, current distribution, future habitat, potential colonization, adaptability, right? Just in general, to pick an area that you're really familiar with in terms of the region, and just think about those species that are present, right? Think about what it looks like when you're in the forest now, and then think about those species that are projected to increase in habitat or decline, and what that would mean to change. That's what we also often do in-person field workshops, which I think is a really great way to then start to think about it. So that's how I approach it, right? And I think it kind of allows you to bring your own knowledge to the system, see where it's missing, right? About, and then see where it can add in terms of thinking about future conditions.
Awesome. Yeah, and we'll definitely have a chance to kind of like, you all can share how you might approach that or do some of what Steve was just saying when we are in our discussion sections, focusing on adaptation. Jake asked a question about the seed lot selection tool, saying it's only available in the West Coast. So it's just that tutorial is specific to the West Coast, those tutorial materials, but the seed lot selection tool itself is nationwide.
Yep. Yeah, thanks for that clarification. Yeah.
All right, I'm not seeing any more questions in the chat right now, and we're getting close to the top of the hour. So yeah, thanks again, everybody, for listening. Thank you, Steve, for sharing and diving into all those different areas and species. We will again be following up with a newsletter and seeing you all at your discussion sessions this week. But if there's any hot lingering questions right after this, you can feel free to shoot us an email, and we can always put you in touch with Steve as well. So yeah, with that, I'm going to stop recording and say thanks again and have a wonderful day.
Thank you, guys. Great presentation.
Thanks, everyone.